Okay, how is it going? How's your weekends? Good? Okay, hopefully you all liked last week. It was kind of a little bit of a break. I think the rest of the semester is like 2 more weeks of classes and then Thanksgiving break. And then right after break is kind of like finals time, right? So yeah, I'm trying to like plan out the rest of the semester, but we have a few more topics we're going to cover. And remember, from midterm exam 2 to the rest of the semester, what we cover, like big O notation, classes, scope, pass by reference, that will maybe be like 10% of the final exam. So not really that much, but classes I think will be on there a tiny bit. So today we are going to be talking about classes and go into a little bit of object-oriented programming, if you've heard that term before. So yeah, we'll do an intro to classes in Python. We'll talk about class attributes. We'll talk about equality with classes and data and things. And then talk more about classes on Wednesday. And then you'll have a quiz on it on Friday. Okay, so classes. Let's say your job is to design at a very high level a video game character. So let's say you're building a game and you have to represent a character in some way. Decide what attributes you want your character to have. So when you're playing some game, maybe think of a game, what might you need for that character? Like if you're building, remember those like Mii things for Wii's? Do you know Wii's? Do you all know Wii's? Yes? Some of you? Okay, maybe not all of you. But yeah, building those, like you had to determine like the hair color, the color of the clothes, whatever. Or maybe if you're dealing with another game, yeah, Sims, you have like health, you have other things. So think about it, take a few minutes. How would you represent a character and what data would you have associated with them? So maybe I'll give you like a minute, maybe not 2 to 3 minutes, but like a minute. And you can like brainstorm with each other, talk to each other.
Brown hair. Oh, okay. Wait, what?
Hi, Precious.
Oh, okay.
Okay, yeah, for those of you that are walking in, let's say you're designing a game. Think about the attributes you would have for characters in your game and what each character would need to have to play the game, I guess. Could be any game. Think of.
Tall. Maybe special.
Okay, here's a lot of good talking. I know some of you are thinking. So, ways in which we've represented data so far, we've seen all these different kinds, right? So a whole number you'd probably represent as an integer, right? A rational number is a float. If you have a series of characters, that's a string. Binary, ones and zeros, true or false, you would use booleans as your data type or data structure, right? And then if you had an ordered collection of items, let's say they were mutable, you would use a list. If you had immutable things, a collection of things, a collection of items, you would use a tuple. And then mapping arbitrary keys to values, we all know that that's how a dictionary is represented. An unordered collection of items without duplicates, we know that's sets, right? So all these different data structures, different data types exist for us to be able to represent the data that we have. So when we're choosing data types, let's say we're dealing with names, we know to use strings. If we're dealing with money and we have to represent that in our program for whatever reason, we can use floats. If we have to count something, integers. If I have a roster or a list of things like a class, like all of my students, I would probably put that in a list. But for example, what if we wanted to represent something more complicated, like the characters in an RPG or a role-playing game, or just any more complicated thing or entity that wasn't just like a name or a number? We could represent a game with data, right? Character data in some certain way. So if we were to design an RPG, what properties would these characters have? Yeah, maybe the different skills they have. Maybe they can throw things. Maybe they can use different things or weapons, right? Maybe they have a health. Maybe they have strength level, speed, agility, all these different things. So yeah, let's say there's health, attack, strength, and defense. So now that we're trying to represent a game character with data, we have to think about these attributes or properties and then change these over time, right? So classes, this is how you would probably interact with a class. And I know it might be overwhelming or weird, but we're gonna talk about it. So in our game, let's say all the characters have like a name and then a strength level, a defense level, and they all start out with health being 100 points. So you can see in that first line, what I'm doing is I'm initializing an instance of this class, which is an object. And then I'm printing out the different attributes that they have using this like dot notation. So this is like what object-oriented programming looks like. You have some object, and then you use the dot notation to get data that is in this object, that is associated with this object, or this instance of a class. So this 15, when you do woody.strength, it prints 15. You can see maybe it comes from that 15 up there, right? And then the woody.health, it prints out 100. I don't see where that 100 is right now, but we'll see that later with our class definition. When we do woody.name, it prints out woody, that string. That probably comes from up there, right, when we initialize this instance. And the woody.defense prints out 7. I'm guessing, I'm like intuitively thinking that probably comes from that 7 up there. And then it looks like I can call this function, or this method, this class method, on woody, and it prints this. So somehow we've determined that this object, an instance of our class, can do all these things and have all this data associated with it. So we'll talk about how you define a class and then how you can get information from instances of that class. So I know this might be the first time you're like hearing this terminology, but I'll try to repeat it and say it over and over again so it kind of sticks. But stop me at any point if you have any questions. So essentially a class lets you define your own type. So remember we have like strings as types, booleans as types. What are the other ones? Integers, floats, right? Now we can, and lists are their own type too. Dictionaries are their own type. Now we can define our own type using classes. So you can think of a class as like a bundle of different things being attributes and methods. So attributes are like the data that a class instance would hold. So for example, my character would have a name attribute, right? And then a health level attribute, strength, defense level attributes. And then methods, for example, this introduce method, that is something that your class object instance can also have. So the class definition serves as a template for its instances. It's like a blueprint or cookie cutter way to then create more objects or instances of the class. So an object is an instance of a particular class. You create this blueprint or this template, and then you can create instances of this class by using your class definition. And this is like kind of like the template of a class definition, but we'll go more into it. Does that make sense? Okay, any questions? Okay. So the class definition almost always has this special method called init. And this is a method that you can define, and you have to call it in this way with the underscore, underscore, init, underscore, underscore. And this is basically the constructor of the class. If you've seen other programming languages, there's an actual like constructor method. In the same way Python is, it's init. So the init is like the constructor of classes in Python. And you can pass in different parameters, which those arguments would then be stored as attributes for your class instances. So I know that might not make a whole lot of sense now, but if we look at some examples, maybe it'll make more sense. But just think of the init method as the constructor that gets run every time you create a new instance of your class, which is just an object. Okay. Any questions? Okay, so when you're defining a class, let's look at our character example. So I have the class keyword followed by character. That's the name that I decide to be for the class. So I'm creating this like character data type now that has these different attributes. So the init method takes in self, and that's like the object of your class instance. And then it also has these other parameters that you want each object and each instance of the class to have. So like a name, a score, and then a defense score. Strength score. I was like, what is STR? Strength? No, strength score, yeah. And then it looks like I'm setting these attributes, health, name, strength, to be the things that get passed in. But health, I automatically give it 100. Remember, each character in our game starts off with 100 points. So it doesn't have to be something I pass in when I initialize that instance. It's already going to have 100 because I put that in the class definition. And then within my class, I have this method, introduce. So I'm saying every instance of this class has this method that you can call, and it'll use and reference self.name, whatever that name is. And remember, we're setting self.name in the init method in the constructor here, based on whatever I pass in when I initialize that instance. Does that kind of make sense? So again, I'm creating this class with the class keyword and the name. And then when I create a new instance of this class, what's happening is it calls the constructor. In this case, it's the init method. So when I say I want to create a new character, when I tell the computer to do that, and I'll show you how we do that, it will call the init method and set these attributes for us. It sets the data that should be associated with the object you create. Make sense? Yes, Yo.
So my question is, comes from the statements you made when you said creating the character data type.
Yeah.
Does that mean in a language like Python, you can't really know exactly what data types there are since you can always create one?
Yeah, so there are like built-in data types that are the very common, like string, integer, whatever, that all programming languages have. But if you want to then customize and create your own data type, essentially, it is like this, creating a class. So technically, yes, there are a bunch of data types that could exist. There's no set amount. But for the data types that are built in, that almost all programming languages have, it will always be kind of like a set list. Does that make sense?
Yeah,
That's a good question. Yeah.
Thank you. And then I just follow up on that. So the ones that are built in, the data types that are built in now, can you, because you can kind of work with
Yeah.
classes, can you alter like some methods and attributes of
The built-in
built-in
ones?
data type?
No, because those are defined by the programming language.
Oh,
Yeah, but when you create your own, you can do whatever you want with it.
thank
Yeah. Good question. Okay. So now we're creating a class instance. We call the name of the class. So see how it says character? As if it was like a function call. And then we pass in the arguments that the init method, the constructor, needs. So let's say in here I defined 3 different parameters. When you initialize it, it has to take in 3 different things. But the self is always what gets passed in when you define the constructor. That's just how it is. So you have to pass in self and then all of the other parameters that you want to be attributes for your class. So that when you create a new instance of it, it has all of these defined. Okay, so yeah, I create Woody and I create Vicky, and then it has these different attributes. Make sense?
So, you have to pass self. So, does the self use Woody with a small w here?
No, yeah, that's a good question. So self is just the object that is the instance of the class. So you can use self within the class definition. So see how it says self.name here? I can reference whatever is stored in self.name because I can reference my own class instance there. But then here, when I pass in Woody, that argument gets stored in the parameter character name. Yeah, so it doesn't map exactly now with classes. Because the constructor, that init method, behaves specially, if that makes sense. In a special way. So it's not exactly like a function call. You're creating a new instance of the class, and it looks kind of like a function call. It's kind of similar to how it works, but it doesn't exactly behave the same way. That's a great question.
Yeah, thank you. And when you said mostly, like you said, in its function, are there some cases where
Yeah,
you don't do
so I've never seen a class that doesn't have an init, but I'm sure you can do weird things. I've never done anything really extensive with classes. I only know like the basics, which is what I'm teaching you all. So that's as far as I know how classes are used, but I'm sure if you were to use Python in a more data intensive settings, you might use classes that don't have an init. I actually don't know. Yeah. But every class that I've worked with, usually it'll always have an init or a constructor. Yeah. Maybe if you have like subclasses, there are other languages like JavaScript has like different classes that can extend other classes. Maybe that and how that works with Python is different, and you might not need an init method or a constructor. But yeah, it gets a little complicated when you start to deal with like complicated data structures. Yeah. But I know I'm a little bit more familiar with like JavaScript, but not so much like Python. Yeah. Okay. Any more questions on this? Okay, so when you create an instance of the class, the constructor or the init method is called and executed. So you can see kind of how this works if you use Python Tutor, and we can take a look together. So I have my class definition, and then I'm calling all of these lines of code to print things. So I initialize an instance of the class here, and then I'm just printing its attributes. So if I were to run this, what happens is it creates this character class, and it looks like each character like type has an init method and then an introduce class method. So when I call next, what happens is it's calling this init method, and it has all of these different parameters. So self.health gets 100, self.name gets character name, which is here, right? And then I keep doing this. So then my character instance of this class has these attributes. So then when I go to print these things, it just references what's here. So here's like the print output. So hopefully that kind of helps to visualize. If you ever need help visualizing what's going on and tracing through code, always use this tool. I think it's a great tool. Okay, let's go back to this. Okay, so for your code to be executable, so it doesn't go into this runtime error or there's no syntax error, right? A class name must also follow the same rules as a variable. So no operators, can't start with a number, right? All these different rules that we learned before. And there's also style conventions that you should follow just to make your code more readable. So like variables have a rule where all the words should be lowercase and separated by underscores. We've learned that, right? Class names should be uppercase and camel case. So all words are concatenated together and start with a capital letter. So if I had team roster, I wanted to make a class that was a roster of teams and each person had its own attributes, whatever, then the class would be team uppercase T and then roster uppercase R put together, no spaces.
Including the first letter.
Sorry?
Including like the first letter.
Yes, including the first letter this time, yeah. I know other cases, camel case is different where the first letter is lowercase, but for Python, when you make a class, all the words should be uppercase. So yeah, one word, just uppercase it. Multiple words, you put them together and then make sure to uppercase every word. So one little style thing. Okay. Any questions on that? The short intro to classes. Okay, let's talk about the attributes that we saw and go a little bit more into that. So attributes don't get stored in like a frame, like how we have a global scope and a local scope. They're stored as part of the object, so similar to how lists and dictionaries have items. The attributes are like parts of your object. That is your class instance, right? So Woody is an instance of the character class, and it has these attributes, which is Woody is name, 15 is the strength level, 7 is the defense level. And there are two ways to really set attributes. So there are two different kinds of attributes. There's instance attributes and then class attributes. And you can think of instance attributes as one that are pertaining to its own instance, and then class attributes are shared amongst all the different objects or instances of the class. Okay, so let's talk about both of them. So instance attributes are set by assigning it to the instance of that class. So they can be set like this inside of the class, like self.attribute name, and we saw that before with like self.name is equal to whatever was passed in as a parameter, right? Or you can do it outside of the class by taking that variable that you created, like Woody. Remember, Woody is like this, so that variable, and doing .attribute name is assigning it to some value that you wanted. And then you can access them inside of the class using our self method, right? So Monica was saying, why do we have this self? Why does it behave different? Well, the self is that instance, that object. So you can do self.attribute name to get it, but you can only access self in the class. Or outside of the class, you can take that variable and then do .attribute name. So this dot notation with object-oriented programming, right? So instance attributes are unique to that specific instance. So when you create a new instance, if it has instance attributes, it's specific to that one. Then when you create a new one, those attributes and those values are specific to that one. Make sense? Okay, so let's look at some examples. So usually every time when you have the constructor init method, you're gonna do this self dot something equals something, self dot something equals something is usually the same thing. Like self dot strength is equal to strength, self dot defense is equal to defense, but to make it more clear, there's like a distinction. So self dot health is equal to 100. Health is then an instance attribute. Self dot name, these are all instance attributes. Then let's say I wanted to set Woody's favorite color. I could take Woody, which is this instance that I've defined here, created here, and then I can do dot favorite color is equal to some value that I want it to have. So then now I could access it by doing this dot notation, right? So then I can access the value of this instance attribute. Same thing here. Instance attribute, all of these, I'm accessing that value by doing the dot notation. Make sense? Yeah, Monica?
So we added Woody our favorite color equals to blue, right? Now, is it going to be stored in the class?
So it's not stored in the class definition. It will be stored in like the instance here. Like if I did it here and I assigned its favorite color, it would be like one of these other instances. And its variables there, or values there. Does that make sense? But it's different than class attributes, which is maybe what you're getting at. So let's talk about class attributes. Oh, yeah, Daniel.
So for this one,
Yeah.
does Woody dot health? So it only changes the health for Woody only. Not
Yes.
everything.
Yes, exactly. Because that's an instance attribute. That's how it works. Okay. So these are a little bit different than class attributes. So class attributes are set directly in the class definition and not in the constructor. So not here. They're set in the class like up here. So, oh my god, why does it say does? These. Okay, these can be set inside the class by just doing attribute name is equal to value. Notice there's no self here, right? Because self is dealing with the actual instance, right? The specific one that you're talking about. And then you could do class name dot attribute is equal to whatever value you want it to have. And this could be inside or outside the class. So now you're putting it on the class, not the self, which is the instance of the class. And then you can access them doing the class name dot attribute, whatever it is, wherever you want, or instance variable, which is like Woody, right? You create a new instance variable dot attribute name. Yeah, Zeal.
Can you say when you use what's the way you use with like self dot? Can you see that's like the default, and if you don't change it, that's what you bring for every object that you create?
Yes, you can kind of think of it like that because it will create, or it will grab the self one first before it looks in the class one. Yeah. I'm trying to think if that's, yes.
Appreciate it.
And then these are shared among all instances of the class. So let's take a look at these lines of code. So when we do birthplace is equal to some value outside of the constructor, that's a class attribute. So it's not specific to oneself, right? It's specific to all the classes that are then we're creating objects of and instances of. So when we do Woody.birthplace here, well, okay, first, it looks like we're creating two instances of the class. that will have their own instance attributes, right? So they each have their own name, they each have their own strength score, each have their own defense score. When we do Woody.birthplace, it's this value because that's this birthplace here. And then Zeal, what you were saying, if I like had self.birthplace and passing birthplace, it would take that one.
So like self.health will remain 100 throughout,
Unless you change it. Yeah. So then character.birthplace, this is now the class, right? It's this value. So let's say we assign picky.birthplace is this. That becomes an instance attribute. Because you're taking that instance and you're assigning it to this value. You're taking the instance, saying that you want to give it this attribute and assign it to this value. So when we do this character class.birthplace, we're assigning it to this value. So it's effectively like changing it up here. So when we do picky.birthplace, that's an instance variable. Or instance attribute, rather. So this character, you already know that's going to be like a class attribute because you're referencing the class name. Now it's Narnia, right? Because we set it up here. So then when you do Woody.birthplace, it's Narnia. Because it's referencing and accessing the class attribute. Make sense? Okay. So just a few things to keep in mind and some errors that we'll see. So don't reference attributes that don't exist. So if I were to do Woody.age, that's not actually an attribute that we've defined or set in our class definition. So therefore, you're going to get an attribute error. The computer is going to say, this can't compile. Let me try to help you figure out what the error is. So character object has no attribute age. So then if you're also trying to access an instance attribute and you think it's on the class, but really it's on the instance, again, it'll give you an attribute error, saying that it has no attribute name. There is no class attribute name. It's an instance variable, an instance attribute, but you have to do the instance of it .name. Does that make sense? Okay. So let's say I was like debugging stuff with this game I was developing, and I wanted to print an instance of the class, and I tried to just say print Woody. This is actually not going to be very useful to me because it gives me the like location in memory of this instance. So if you've ever like printed a function on accident, it gives you like function, right? And then some weird like character ID, something, whatever. Some sequence of characters, right? That's like giving you the location of the function in memory, which is so not useful to us, right? So instead, we've kind of seen this before, the string method, right? We've seen it before when we have str and we can cast things as strings, right? So now when we define the string method in our class, we're saying that we want to create this string method for our class now. So now it's kind of like we're building this for our specific customizable data type. There's this built-in one, str, but now we're creating one for our type now, our class, whatever it is. So essentially it tells Python how to represent our class as a string. So that when we print the class, or print an instance of the class rather, we can actually get some useful information that's not just its location in memory. So it's always named underscore underscore str underscore underscore. And it always takes in self as the only parameter to represent that current instance. So when you print that current instance, it will take in that self and then print whatever you want it to, you define it to, and it has to return a string. However that string you want it to look like to represent your class. And what it means, this will make more sense when we see an example for what that means. So basically we have to tell Python exactly how to print out an instance of the class, whatever it is. So in our example character class, I can define this string method, but it has to look like this. It has to do underscore underscore string, underscore underscore pass in self, right? And then I can return some sort of string that is a good representation of what an instance of a character would be. So maybe it makes sense for me to print out the name of the character and then the strength and then the defense level of that character. You could also have it print health. You could have it print whatever you wanted, but you want it to be useful to you. So that if you ever needed to debug and print something that was useful information, that's how you'd want to structure your string method for your class. Does that make sense?
Yes.
So like if you call the class,
Yeah.
this would.
What do you mean if you called the class?
That's actually the question. Like what would this do?
Yeah, so the way that you would like use this,
Yeah,
now you print Woody. Under the hood, behind the scenes, it's going to call the string method.
Yeah.
Because print under the hood actually uses string. Yeah.
Okay.
Yeah, so now it would print this, right? And that's so much more useful to us than its location in memory,
Yeah.
right? So now it'll print the name, all of the attributes that you might want to know at that time in your program. Make sense? Okay, any questions on this? Nothing? Okay. So another similar thing to checking like how to print a class, we can check if one instance of a class is equal to another. But it's going to be in like the similar way. So we haven't learned the is operator before. So objects that are instances of classes that you define are immutable. So you can change the different attributes, right? We've seen that before. We've changed like the health and the whatever strength level, defense level. So therefore it's passed by reference. That's just like a side note. But we can use the is operator to check if two variables refer to the same instance. So I have these two characters, which is like two instances of the class character, Woody and Picky. And if I did Woody is Picky, that would print false. Because those are two separate instances of class. It makes sense that it returns false, right? Woody is Woody. I'm comparing Woody to Woody. Of course, it's going to be the same thing. So it prints true. This statement evaluates to true. Make sense? Okay. But if we were to do this, where we have two different characters that have actually the same exact values, when I do player 1 is player 2, this is going to be false. So even though they have the same exact attributes, they're created in the same exact way, they're still technically different instances. So the operator, this is operator, doesn't compare the attributes, it checks if it's the same. It checks if it's the same in literal memory location. So that's what it's checking. Is this thing in memory location A whatever the same as whatever is this thing in memory location? So it's comparing the two different memory locations. So the is operator checks if two variables are in the exact same instance, meaning that they're in the same exact memory location and where it's stored. The equals operator, remember, checks if two variables have the same value. And we've seen this before, right? So if we were to do A is sum list 1, 2, 3, and B is sum list 1, 2, 3, and we set C is equal to A, remember what that does is creates a pointer, right? And it says, now C is just going to point to A. So if I change A, then it'll also change C. So when I do A is B, that's false because those are two different things in memory. A is created in memory somewhere, B is created in memory somewhere, but even though it's the same values, it's not the same exact instance. So it prints false. When we do A is equal to B, that's true because it has the same values. That's what the equals operator is doing. And then if we do A is C, well now that's true because it's actually pointing to the same thing in memory. So C and A are basically the same thing because it's pointing to the exact same thing in memory. Make sense?
Yes.
Okay, so if we wanted to check if two classes have the same values, then technically speaking, we should use the equal operator, right? Because it means that, or equal means that you're checking the values. But if we were to do this right now, it would actually print false. So that's where this equals method.
Sorry.
Yeah.
It's kind of go. But I thought before,
Yeah.
like, can you go back on the slide?
Yeah.
Yeah, I thought, okay, not for classes.
Yeah. So this is for values with the other data structures we've seen. This is how we've seen it with other things, but with classes it's different. You have to actually define how equality is checked with classes. Because this doesn't work out of the box. Because how like lists are working and built, that's how the programming language has defined it for you. And you can't change it, right? We talked about that earlier. But classes are customizable. You create your own type. Therefore, you have to create how you check the equality of them. Right? How you print it, you have to use the string method. How you check equality, you have to use the equality method. Or equal method, whatever it's called. So if you want to tell Python what it means for two instances of the same object to be equal, you have to use this method. Because again, it's not built in for us like how strings behave and how lists behave. That's just something we know because we've done it over time and that's just how Python has defined for us. So that equal operator works in this way for Python. But if we create our own classes, our own data types, right, we have to define how those are equal. So that's where this method comes in play and comes handy. So again, it's always going to be this syntax, underscore, underscore, EQ, underscore, underscore. Takes itself as the first parameter, again, to represent that instance, because we only want to compare instances to each other, right? So it takes a second parameter to represent the other instances being compared to. And it has to return true or false. Of course, that makes sense, right? Of course, it's going to have to return true or false, otherwise it's not going to work. So if we want to tell Python, in our case, how two characters are the same or equal, we define this class method, this equals in this way, with self, and then I think the other could be whatever you named it to be. It doesn't have to be other specifically. But you would say, okay, if the names are equal of these two different instances, then the characters are the same. So that's how we've defined it in this case. But you could have defined it any way you want. Maybe you would also check if string scores are the same or defense levels are the same, right?
Oh.
Make sense?
Yeah, so, oh my. Oh. So it's like equality. Sorry.
No, it's
what I
okay.
was ask is, you can, sorry, it depends on what you want to be equal. That,
Yes, exactly.
oh. So if you say like defense makes two characters equal,
Yeah.
you can set it down.
Then that's how you've defined it to be equal. Yeah. So it's up to you because you're creating this type, right? So now, if we were to check player 1, that instance of the class character, player 2, and use the equal operator, now this would be true because it's comparing the string Woody to the string Woody. If 15 and 7 were different and all those numbers were all different, it actually doesn't matter. Yeah, it would still be true. Yeah. So in this case, all the numbers are different. It's still true because that's how we defined our equal method to be. Okay, any questions on that? Nothing? It was all clear? Okay. So we're going to talk more about classes on Wednesday. And then you'll have a little quiz on it on Friday. So reminders, Project 2 Part 3 was released this morning. Hopefully you all saw it. It is again building a simple search engine, but now you're using dictionaries. So the last person that hasn't submitted a part yet will be the one to do it. And make sure you read the instructions because they are different this time than the last time. So just be very careful with the instructions. And then I've given you a little bit more time. Monica asked for this, so you can all thank Monica. But yeah, it's due Wednesday instead of Monday, so you have a little bit more time.
Like next week. Okay.
Yes, sorry, next Wednesday. Next Wednesday. Yeah, you have more than a week. Yeah. And then for the design doc, we're going to be grading you on the quality of the design doc this time.
Quality.
The quality of how well you write the design doc. Yeah.
What do you mean by
What does that mean?
Can you explain?
Yeah.
So there are examples that I put as references in the template. try to like match the quality of those ones. Yeah.
Okay.
So it's just like write. It's a little bit more clearer. Yeah, detailed, a little bit more articulate. Don't just write random stuff. But I mean, everyone's done a great job. But I think I want everyone to just really be intentional with how they're writing that doc. Yeah.
So sorry.
Yeah.
Sorry.
It's okay.
My integration test is equal to 200%.
200%.
Yeah.
What do you mean?
Like.
What?
Sorry. Like in first for the project 2, the part 1.
Yeah.
Some like just not because of it. Some people like go 200%. Yeah.
Oh, really?
Yeah. And I was
Okay, wait, I think there's something wrong. Then I think I did the code to like make that grade wrong. Yeah, let me fix it. Because there's no way to go over
100%.
100. Yeah, sorry. Thanks for letting me know. I need to double check that. I think I was rushing last time uploading the grades. So, yeah, I think there's something wrong with like my code.
Oh, because I was
There's
kind
a
of
bug.
afraid.
No, there shouldn't be 200%. Maybe there's like some error. Yeah, let me fix that. But yeah, we will be finished grading Project 2 Part 2 soon too, so I'll fix all the grades then. But thanks for telling me. Okay, yeah, nothing, you can't go over 100. Okay. Homework 11 is not released yet. It's released tomorrow, and it'll be due next Wednesday. So it'll cover all these different topics that we've been talking about: scope, pass by reference, pass by value, and classes. And then quiz 9, is it quiz 9? Yeah, is going to be this Friday, and it'll just cover classes. But it's all, everything's kind of related to each other, like functions, classes, scope. So yeah, it should be classes mainly. And then don't forget midterm exam 2 corrections. You have less than 2 days to complete it now. It's due tomorrow, so whenever the last office hours are for the TAs. And then what else? Okay, final exam. So the final will be during your lab on Tuesday, December 3rd. So hopefully that works for your schedule. Maybe it's a little bit earlier than your other finals. And then worst case, it'll just be in the lab room, but I want to try to get a bigger room where you all are more spread out. So you're not like really close to each other, and if people walk in and out, it's not disruptive.
Yeah, like okay.